So I see the radical here. It's the square root of y minus 2. It's not alone. There's this minus 1 that's on the same side of the equal line. So we have to isolate it. We'll add 1 to both sides. That's your first step. So the new equation is y minus 2 equals 6. Step 2 is to raise both sides to a power. And it's whatever power is in the index. So this problem has an invisible 2 with the square root. So what we'll do is square both sides. The exponent and the square root cancel out because they're inverse. And now we have y minus 2 equals 36. And then you have to do whatever work is necessary to solve the resulting equation. So here I would add 2, and y is 38. So you gotta check. A lot of your checking can be done mentally, but I will ask you on your test to show the checking. So I'm going to plug it in. And then I will simplify. So go back to the original problem, plug in your result. The square root of 36 is 6 minus 1. It all checks out, so this is a good solution. It's non-extraneous. Questions? Okay. Anybody want to take a picture? Or want me to wait a minute? Alexis, you gonna do the next problem? Let's do it. We'll put a line through it. No solution. It'll be a no solution. Nothing works. Okay, next question. So I did all this work and I got y equals 38. I put 38 in the problem to see if it's a true solution, and it is. In a couple of examples, we'll see one that won't work. Alright, so there's more than one radical in this problem. That means step 1 can't be done. You can't isolate when there's more than one radical. We're not going to move things around from here. We're going to go straight into step 2, which is square both sides. Raise both sides to a power of 2. So I'll put parentheses here, 2 on the outside. A parentheses here, 2 on the outside. So over here, this is awesome. The square root bar and the 2 will cancel. Over here, a lot more complicated. We can't distribute into this difference, so we're going to have to write it out side by side and do a FOIL or a double distribution. This problem takes like 8 more steps. This is a really long problem. So 2 times 2 is 4. 2 times the negative square root of x will be negative 2 square root x. Negative square root x times 2, same thing. And the square root of x times the square root of x is the square root of x squared. And those two negatives will make it a positive. So combining like terms, those combine here. And the radical and the exponent cancel here. Any questions about how we got this far? So now we kind of start the whole process over. Now that we've got it down to one radical, we're going to go to step 1, isolate the radical. So we're going to do all of our inverse operations till this guy's alone. So just move things around. It's a positive 4. Actually, let's subtract this x from both sides. That cancels it out. And I'll just pause here for a minute and let you guys do like the next 3 steps. So you remember talking about how like if there's a 3 here and a 3 here, that it cancels to just the x. So that's the same concept here. It doesn't matter what's under here. This could be anything. If this is a 2 here and this is a 2 here, all that's happening is the radical and the exponent cancel. Reviewing what that is, because those are inverses. Okay. Like right here, this looks curious to me. Square root's never negative. Oh, yeah, positive. Positive 4. Alright, so we'll pause there. Any questions on how we get to positive 4 equals the square root of x? Moving things around, dividing. So now that's isolating the radical. So now we'll raise both sides to a power of 2. And 16 equals x. So, check it. Has anybody checked 16? Checking right now. see that, Max? Max, you see it? Did you check it? It's really important. It doesn't work. Well, if the two sides aren't the same number, it's a contradiction. It doesn't work. So there's no solution. So what happened was is in the process of squaring, we kind of lost this possibility of a negative. We created, like right here is when I realized that something was interesting about this because of the negative. Kind of hard to predict. But in the process of squaring both sides, we resulted in this contradiction. So we're going to go ahead and go back to our answer. We're going to put a line through it. It doesn't work. And this is now a no solution equation. All of that work just to have no solution. Yes. So would it be it would be just enough to put two lines on there too? No, I'd like you to go back and put a line through it. We don't want to leave that. And state no solution. Okay, good. That was a long one. I'm gonna go to one. Here we go. Let's try this one. This one has a cube root. So you can work this with that rational exponent, but it's usually just a lot more recognizable if you want to put it in radical form. So if the problem's presented, it goes both ways in this section. It's kind of lumped together, radicals and rational exponents because they're the same thing. If the problem's presented with a rational exponent, go ahead and rewrite it as a radical. It's not like necessary. Like I could raise both sides to the power of 3, but you'll just find it a little more recognizable. Okay, so here we are. We need to isolate the radical. Matthew, what do you think? Right here. How am I going to get rid of this radical so I can dig in and find that y value? It's step 2. Did you write the steps down? No. Joanna? It's a cube root, so we're going to raise both sides to a power of 3. This time, cube both sides. Because whatever the index in is the power you raise it to. So this time we do a power of 3. The other two we squared. Now we're doing cubing. So 3y plus 1 equals negative 125. Max, why aren't you practicing this? Why aren't you doing this? You didn't do this one? Yes. You see me? Everybody's all worn out. Is this like 36 or something? 42. Ooh. So y is negative 42. Sure. I feel really good about it, but I'll have to check it. Put it into the original, check it out. And if you guys feel good about this one, we can start your assignment after this one because I give you a bunch. Some time in class to do it. It's X out. Good news. Checks out. That's a good solution. Much shorter than the last one. So you'll find that the problems with radicals on both sides are going to be the longest. It's not the case in your homework, but like example 2 that you did, those are the longest ones. So let's go ahead and open that workbook up and get some of those done before you go. I gave you 7 through 16, and some of these are long. Page 89, 7 through 16. I don't see any on here with radicals on both sides. 15 and 16 are actually really short because they're just plain radicals. This is it, you guys. This is your last section. So we'll practice this again tomorrow, and then we'll just review for your test. This is the last new thing you have to learn before your test on Tuesday. All right, I have a little invisible 2 here. So I'm going to raise both sides to a power of 2. And Kaylin, your question about this was right on point. That 5 does not square. It just stays a 5. Sometimes we'll accidentally do that even. And now I will do whatever it takes to solve for the variable. And that's a good answer. Yeah. Yeah, you do. Sure, skip to like, okay, your lunch day is 15.
Ain't no way. Oh my god. That's so bad.